In this tutorial, we will further explore various options to define functions in BISTRA. We will begin by further zooming in on the default template functions. Thereafter, we will learn how to link the climatic data in EPW or TMY format. Finally, we will explain how any user-defined function can be generated. We shall continue working from the exercise of the previous tutorial. Also, corresponding exercise files are available to download from the link mentioned in the description of the video. Click on the functions icon at the top toolbar. Then for the function T01, where the internal temperature was previously defined using a sine curve, change the type by double-clicking on it. Then we see other template functions. As we can see from this illustration here, we have 5 templates: Step 0, Step 1, Step 2, sine and positive sine functions. We will use Step 0 for this example. Each abbreviation's description is mentioned at the left bottom of your screen. We can visualize the graphical preview of this function. Then for T02, where external temperature was previously defined using a sine curve, change the type by double-clicking on it. Now from the list, choose EPW as we will link it to a weather data file. You could download EPW files from various sources online. You can refer to the BISTRA manual for the requirements of the EPW file. In this example, we use a EPW file for Brussels. At the Functions window, click on the file name and then choose the EPW file to link the data. EPW contains annual weather data for 365 days. To zoom in, make a rectangular selection using a left click. Alternatively, you can use the scroll wheel to zoom in and zoom out. Suppose we wanted to run the analysis using outdoor temperature from the EPW file for 2 days in the winter. Say from 1st of February. Click on Calculation Parameters. Now we need to set an appropriate start date. For guidance, click on the eye icon. Here you see reference start dates corresponding to each month. Day 32 corresponds to February 1st. Now you can close the guidance window and input the start day as 32. Say we start the calculation from 4 p.m., so it will be 16 hours. Then we need to set the time step to 1 hour and the startup duration to 1 day. Now set calculation duration as 2 days. Open the functions window again. Here internal temperature is still linked to step function where it fluctuates between 16 and 20 degrees. For outdoor temperature, we pick the temperature profile for 2 days from February 1st from the annual weather data. These temperature functions are linked to the boundary conditions via the reference T01 and T02 in the color window. You could also visualize this 2-day profile by clicking on the Functions menu, then choose X Scale. Currently, it is under Function Scope, so we change it to Calculation Time. Then, the function graph updates to display the profile only for the time duration mentioned in the calculation parameters. At the beginning, from -24 hours to 0 are the temperatures required for startup calculation duration, which is 1 day, on January 31st. Then temperatures for the next 48 hours are shown, which is from February 1st to 3rd. You can revert this to display the temperature profile for the entire function period, which is for 365 days, by clicking on Functions X Scale and then choosing Function Scope. Lastly, before we run the analysis, check if you turned on the Save Frequency from the Calculation menu. This enables us to visualize the result in graphic output. We now run the analysis. You notice calculation happens first for negative time steps, which is the startup duration, and then for the calculation period, which is 2 days. Upon completion, click on Graphic Output. We will now adjust the graphical scale by clicking on the temperature range and setting the minimum to 0 and the maximum to 25. Click on the next time step to visualize the results for the next analysis time steps. You now can close the graphical output and open the Functions window. We can also link the TMY3 file, which is also an annual weather data file in .csv format. Apart from temperatures, weather data files can also be used as sources for global horizontal radiation and horizontal diffused radiation functions, which will be illustrated in the next tutorial when introducing the solar processor in BISTRA. Next, we will learn to input customized data for a function using an external file. All the parameters shown in the functions window can be through a user-defined function. For this exercise, you can download the data file concrete.fla from the link mentioned in the description and then save it in the same location as that of the project file. We will create a new function using a customized data curve to define thermal conductivity as a function of temperature. Each data file has a unique extension corresponding to various parameters like temperature, surface heat transfer coefficient and so on, as shown here. Apart from time-changing functions, it is also possible to have temperature-changing or angular-dependent functions with their corresponding file extensions as depicted here. You can further read in detail at BISTRA manual. You can directly open it from the Help menu, click on the manual, and then go to Chapter B.12. Functions window. Even if there are a lot of possible parameters to define using an external file, this example will restrict only to temperature-changing function for the material conductivity. So, the external file will have an extension of .fla. Click on Insert after to create a new function, then input the reference number as L01. At the Colors window, input the conductivity of the concrete as L01. Now the function is linked to conductivity. The external file contains the data to define the function curve. You can also check and edit this data by opening the file through Notepad. Here on the left column, you see the temperatures, and on the right column see the corresponding thermal conductivities. In Chapter G of the BISTRA manual, you can further learn to create or edit these external function files. In addition, climatic data files can also be custom created as an alternative to EPW or TMY files. Guidance to this procedure is available on the Physibel knowledge base with the title F3, Preparing Climatologic Data in Physibel Software Format. To summarize, for this calculation, the indoor temperatures are defined using a built-in step 0 function, and then the outdoor temperatures are directly linked to the weather data file, and then the conductivity of the concrete is a function of its temperature defined using an external file. We now will run the analysis to visualize the results. Choose Yes to recalculate triangulation. Upon completing, open the graphic output. Here you can check the temperature profile for each time step. At the text output, open the report output. Here you can check the data for each of the report definitions. We learned how to create these report definitions in the previous tutorial. This is available from the Edit menu and then choose Report Definition. Thank you for watching, see you in the next tutorial.